Hi guys, so we are going to work on coloring in our periodic table right now and labeling it so that you understand how to read it. So what you're going to need is 4 different colored pencils. You could also use different colored pens if you have them, or different colored, don't use markers, but if you have like a fine tip marker pen, you could use that. You could use one color pen also, that's fine. I'm just going to write in different colors so that way it's easier to read different ideas that I'm putting down. And we are going to get started. So remember, since this is a recording, you can always pause it if I'm going too fast. Or what I would recommend you doing is watching everything that I'm doing and then pause it so that you have the picture in on your screen, and then you do what I did. So watch everything first and then pause what I just finished. So we're going to start with our colored pencils and we're going to color in the periodic table. So start with the color that is your favorite color. And we're going to make, my favorite right now is going to be the pink. So we're going to make boxes. I'm just going to zoom in right up here so you can really see what I'm writing. We're going to make 4 boxes, and then we're going to label what each color means. So this is our key right up here at the top. So we're going to use favorite color up at the top. So I have like a pinkish color. And then it doesn't really matter what you do next. We'll do another color here. And then another color. And then your last color. And if you're worried about messing up the periodic table, you might even want to watch the whole video or fast forward to the end so you can see the end product so you kind of have an idea of how you want to do this. Before we start writing down what each of these mean, just so I don't forget, we're going to go over here to the periodic table and use your pen, or you can use a marker for this one. And we're going to make like a staircase because that's going to help us when we start coloring in to make sure we don't go too far. Okay, so you should see that staircase. I'm going to leave that up for a few seconds so you make sure you have it. And we're going to pick up that favorite colored pencil that you like. And I want you to make sure that you very lightly use this. You're not going to scribble in really hard because you need to be able to read everything that's inside the box. You're going to skip the H. So start with 3, 4. You're going to go all the way down. And then you will do the A. Just going to do the outline of what you want to do first before you color it all the way in to make sure you don't mess it up. The GA below it. Then we're going to, actually this whole row, that way we don't mess it up. All right, so the SN gets colored in. And below it. And then the BI gets colored in and the PO gets colored in. Okay, and then you can just color the whole thing in here. Again, we're not trying to push too hard, nice and light. All right, then we're also going to do these 2 rows down at the bottom. So everything down at the bottom is going to get colored in. Okay, so we can now put aside this colored pencil, and we're going to pick up the next color that you chose. And I use green for the next one. All right, and that's going to go on your staircase. So over here, we're going to start with the B. The S-I and G-E. The A-S and S-B. The T-E. And then the A-T. All right, and then we are going to use your third color. So my third color is orange. And we are going to do all of these nice and light. And we're going to leave Tennessean white right now. They're not 100% sure if it should be green or which color it should be, because it is a man-made one. And you can tell it's man-made because it's not colored in right here. So I was trying to figure it out last year. I looked it up online, and they're still, because it's man-made, it doesn't last for very long. So it kind of has some qualities of it's probably a metalloid, where it can kind of go between the non-metals and the metals. It has both, but we're just going to leave it blank because we're not really going to use Tennessean anyway. So it doesn't really matter. And then we're going to also color in this H, hydrogen, with that same color. So again, this is, you can kind of tell that this is my orange, and underneath it is pink. So they are different colors. All right, so everything should be colored in right now except for Tennessean. We're going to take the last color that you chose, so that's my blue, and we're going to actually go over 2 of the ones that we've already colored in. So HG, which is right over here, mercury, we're going to color that in blue. Again, don't make it too dark, or whatever color you're using for your 4th color. The reason we're doing 2 colors is because it is a metal, which is, we're going to explain what this color means, but everything that is this color is a metal, but it is actually a liquid. So instead of being a solid, there are only 2 elements on the periodic table that at room temperature are a liquid, and mercury is one of them. And the other one is over here with the non-metals, which is bromine. So again, it is a non-metal, it's not a metal, which is why we colored it in the one color first, orange for me. And then I'm just going over it in blue. So it does kind of stand out. So they do look different. Okay, so now I'm just going to zoom out so you can see what it looks like. I'm going to give you a few seconds to pause it so you remember how to color everything in. And you are now going to get your pen. You can use a pencil if you want to and go back over it. But maybe you want to just wait and see what I write so that you know how big to write before you actually fill all this in. But we're going to fill in that key up there at the top. So I'm going to, like I said, I'm going to use different colors so that way it's a little bit easier to follow along with. All right, so hopefully if you are done coloring it all in, unpause it. You should have unpaused it by now. So we're moving up to the top to fill in our key. I'll zoom in as much as I can so that way you can be able to read it. All right, so the first one, that pink, it keeps getting blurry. Sorry about that. Okay, so the pink one, like I said before, these are our metals. So we're going to label it metals. And we're just going to write some properties about metals so that we remember what a metal is. It has a luster. That means that it's shiny. It's solid at room temperature, except for mercury, of course, but that we have a whole key for the blue, the mercury and the bromine. So solid at room temperature, they can conduct heat and electricity. They are malleable. So malleable, if you ever watch Tom and Jerry, you would see Tom chasing around Jerry with a mallet. So you should know what a mallet is. It looks like a hammer, like rubber hammer. So malleable means that it can be hit with something like a hammer and it would be able to be bent into that shape, whatever shape you're trying to carve it into, or mold it into using a hammer. So it won't break, it won't shatter, kind of like if you take your dishes and you hit them with a hammer, they will shatter. So malleable means that it won't shatter if you hit it with a hammer, and they are also ductile. So that means that you can actually take a piece of metal and stretch it out to make it like a wire. So this is a copper. Obviously, it's malleable. It's ductile. It conducts heat and electricity. It's a solid at room temperature. You can see that it's shiny. There's some shine right there. So this, you should all know what a metal looks like anyway, but this is a metal. Okay, the next one we have is a metalloid. So the metalloids are right along that staircase here. So we did that in green. I don't have green, so I'm just going to write it in a blue. So we have metalloid. And this has a mixture of metals and nonmetal properties. And we don't need to write what those are because we already have our metal properties, and underneath it we're going to be writing our nonmetal properties. Okay, so the next one, again, you guys can just pause it if you need to continue writing. The next one are our nonmetals. So our nonmetals are the orange ones. They're way over here. We have some gases, but we also have some solids that are not metal. And properties of nonmetals is that it lacks, it's basically everything the opposite of our metal. So it lacks luster. They don't conduct heat or electricity. Non-malleable. And usually they are a gas, but they are not always a gas. So for example, I don't know if they still do this in 6th grade, but when they do rocks in 6th grade, they talk about sulfur, and they would have passed around this like yellow, it looks like a yellow rock, a yellow mineral. And sulfur smells like a rotten egg if you've ever smelt it, or if you did get to see it in 6th grade. So that is not a metal. It doesn't shine, it doesn't conduct. If you hit it with a hammer, it would just shatter. But it's not a gas. That would be one of our solid nonmetals. Okay, and then the last one, I'll use purple for that, is, I've already said it, the two blue ones that we colored in, or whatever color you used, those are our liquid at room temperature. Okay, so I'm going to zoom out again and give you guys a few seconds to copy that down. And then I'm going to go into how you read each of these boxes. So each of these boxes are really important. They tell you everything that you need to know about each of the elements. And you can see here that we have a box that has a line so that we can label it. All right, so this is boron. That's the name of the element, the symbol B. This this is the clearest periodic table that we could actually find on the internet. Usually you have the small number at the top and this number that's a decimal down at the bottom. But if we label it, you should understand it no matter what periodic table you're looking at. So this number right here, this is called the atomic number. All right, and the atomic number tells us the number of protons the atom has. Now, once this number changes, if you look at the periodic table, it goes from 1 for hydrogen, and then it goes on to 2 for helium, and there's not repeating numbers. Each time the number changes, we get a new element. So if this number of protons changes, if this becomes a 6, for example, we now have carbon instead of boron. It's a completely different element. So the number of protons will never be different if we're talking about that particular element. It also tells us if it's a stable atom, it will tell us the number of electrons. And you should know by now from the Storybots episode what a stable atom is. So it tells us the number of protons, which would be 5, but would also tell us the number of electrons if it's stable. So if this is a stable boron atom, there would be 5 electrons as well. All right, the next number over here, I'm going to use a different color just to not confuse you with ideas. This is the atomic mass. All right, and the atomic mass is an average. It tells us what the mass of that atom is in a sample of all the atoms. So we know atoms are teeny tiny, we can't see them. So if we take a sample, the mass of all the atoms would be 10.811. This mass comes from the protons, which is 5, and the neutrons. So let's do it this way. We have so we can see it's the protons plus the neutrons. And that means if I want to find how many neutrons there are, first I would round the number to the nearest whole number. So this, for example, would equal 11. We'd round it up. And then I would subtract, so second, subtract the number of protons, my atomic number, from my atomic mass. And that would equal my number of neutrons. All right, if you are confused about this, let me know. But basically, we round that up to 11 minus 5. Let's see if I can fit it in. I'm going to use a different color. All right, so we'll put it in parentheses. So 11 minus 5 would equal 6 for my number of neutrons. I will explain in another lesson where the decimals come from. Actually, I probably already have at this point. All right, so the B, that is just our symbol. It is always going to be I'll make lines over here, 1 to 2 letters. First is capital. All right, the second or third, sometimes there's a third if it's a man-made one, for example. If there is a third level, they would be lowercase. The first is capital, the rest are lowercase. Okay, and then that last part of our box right here just tells us what our element is. So this is the element name. All right, you can write name for short, but for the periodic table, you can write element name for what we're doing here. All right, so now we're going to go into, now that you understand how to read each box to identify the elements, we're going to understand how to read the whole periodic table to find other information. So we're going to start up here. Again, if you need to pause it, let me zoom in for a little bit so you guys can see that a little better in case you need to pause it and couldn't see what I was writing. I'm giving you a few seconds. Pause it now. Make sure you have everything written down. All right, and we are going to move on to the top over here. So we are going to actually number now. I'm going to use purple. I'm going to use blue to make it stand out a little more. We're going to number the top of each of the columns 1 through 18. So there are 18 columns, so we're just going to number it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh. Okay, so I kind of ran out of space here, not thinking about the numbering. Where can I write it? 12, so make it a little small. 13, 14, 15, 16, 17, and 18. All right, I'm going to take a different color now. So let me just zoom out so you can see I just numbered across the top each one of the columns 1 through 18. And now I'm going to take a different color and circle my number 1, my number 2, and then I'm going to skip over to the 13, but I'm only going to circle the number 3 here, the number 4, 5, 6, 7, and 8. All right, so take a second to pause it if you need to. So I only circled 1 and 2, and then the 3 through 8 of the teens. All right, on the number 1, I'm just going to make a note. Why did we circle this? So this tells me something about all of the atoms in this column. So this has the same number of valence electrons. So all the ones that we circled are the same number of valence electrons. Now what I did in blue, because those are the original numbers, so 1 through 18, so hopefully you understand the ones that we circled. You know what, I'm actually going to write. So this is the ones that are circled, are the same number of valence electrons. That means this whole column here, they all have 1 valence electron. This whole column would have 2 valence electrons. These ones in here kind of change, which is why there's no rule for them. So we're not writing anything about their valence electrons. This whole column has 3, this whole column has 4, 5, 6, 7, and 8 valence electrons. You'll understand what that means in a little bit. All right, so what I wrote in blue, the 1 through 18, we're going to also explain. This is either called a group or family. and it depends on who you're talking to about the periodic table. So all of the columns are groups or family, and they share the same physical properties. And it's easy to think about that because if family, especially your family, you can usually see the resemblance in physical properties, but also same thing with your friends. Maybe you don't physically look the same, but usually you have some interests that are the same. So we group same physical properties for our elements. They are called families or groups. All right, then we have, let's go over here. So let me zoom this out so you can see the whole periodic table where we are right now. So we have a lot of information going on right now. All right, we're going to talk about, let's name all of the periodic table. So I'm going to use gray for my colors. And we have all of this, like we already said, there are metals. But each group of metals or family of metals or area, big area, have different specific names. So this down here, this whole column, family group, is called the alkali metals. Okay, so those are the alkali metals. These guys right here, I'm going to write a smaller arrow so I can fit more in, are the alkaline earth metals. Okay, so I'm going to zoom in so you can see that. So we have the alkali metals in the first family. The second family are the alkaline earth metals. All right. Now these guys right here, if you notice the numbers, we have right here, it goes 56, 57, and then there's nothing there, and then it goes to 71, 57 to 71, and then 72. If you look down here, we see 57 to 71. So this actually belongs right up in here, so where these two are, and that it is named for you in here, but sometimes there's just like a line. So if you want to use that marker again and kind of draw a line, and then this goes up into that line. So the reason they make the periodic table look like this, they actually just take this section out so that it all fits together. So if this was crammed up here, the periodic table would then take up 2 pages, which makes it inconvenient if we're trying to teach it and put it all together on 1 page. So just know that these metals actually do belong up in that area. And we know that because of their numbers. And each of these rows have a name. So this is the, you can see up here, the Actinoid Series. And then this right here is the Actinoid Series. I'm trying to zoom in, but let's see if I can do that this way. Okay, give you a second to write that down. All right, and then we have up here, I know we already have a lot going on in this section here, but between where we didn't circle the numbers, where we can't identify how many valence electrons they are based on the family number they're in or the group number they're in, these are all called transition metals. So let's see. I am going to I really wrote this close. Let's do it this way. I'm just going to kind of underline it here. All right, to distinguish, and then we're just going to make a line up here, and these are called the transition metals. And now when we're over here, these are usually just given, the names of them are given by the first element in their in the family. So this would be the boron family, this would be the carbon family, the nitrogen family. So boron, usually we don't, for right now, we're not going to really need to know these middle ones, so it's okay. But for us, if you want to refer to the family, we'll use boron, carbon, nitrogen, oxygen. These last two do have different names, though. So we'll go ahead and write. They do have different names also, but we're not going to usually refer to it that way. We're going to use this. All right. So this one here, where it starts with fluorine, this is the halogens. And then this, important to remember because we will refer to this last row a whole lot because it has special properties. These are the noble gases. Okay, so now I'm going to zoom out and we're going to talk about reactivity. So when we talk about reactivity, sorry, it's starting to white out here. I don't know why it's getting so light. Let me try to darken it. Okay, so when we're talking about reactivity, that means how likely the elements are to bond. So let's just talk about some of the ones that you guys already know about. So we know, for example, you don't have to write this down, but we know H2O. That's the one that you guys know of most. All right, so O is oxygen. And when it bonds, it actually looks like Mickey Mouse. And I'll use different colors to show you. Actually, you can write this down on the back if you want to take notes. So this is our oxygen. These are our hydrogens. All right, if I look over on the other side for oxygen and hydrogen, I see that oxygen has a valence electron of 6, and we want our goal, let's actually go ahead and write a note. The goal is 8 valence electrons for bonding. So it's kind of like if I built a house, if I was going to build an apartment complex, rather, I don't want to just keep building up until, actually, never mind. I'm going to go into that at another time. I just want you guys to focus on the periodic table with the bonding right now. So sorry about that. I'm going a little too far ahead of myself. All right, so we saw that oxygen had 6 valence electrons, and our goal is 8. And if we look up here, so we have the 6 for oxygen. And if we look over here for hydrogen, hydrogen has 1. But if 6 plus 1 plus 1, that would equal 8. So it's very likely or very easy for oxygen and hydrogen to bond because that makes our goal of 8 valence electrons. So we have our 6 plus 1 plus 1. So total of 8. So we're happy. All right, so we're looking at, oops, going the wrong way, sorry about that. So we're looking at these top numbers here, and we're seeing that 7, where do you think 7 is most likely to bond? 7 only needs 1 more, so 7 is most likely going to bond with number 1. Now, number 1, These are so highly reactive that actually if they were exposed to the air, they would explode. So usually if you capture them, if you get them in a pure substance, you would put it in oil, in a container in oil, so that way it doesn't get exposed to the air. They're very highly flammable also, so you need to protect them. So 7 and 1 are very highly 7's not highly reactive, but 7 would bond with 1. Same thing, 6 would bond with 2, or 6 and 2 ones. 5 and 3 could bond. So another element or another molecule that you know of is table salt. Hopefully you've heard of table salt before, and that's NaCl. So if we just look at Na is 1 and Cl is 7. So NaCl bond together to make table salt. Both very toxic by themselves, but together it's something that we actually need as part of our life to survive. All right, so number 8, this family, the noble gases, these guys actually don't want to bond with anybody. They are totally happy because they have their 8 valence electrons. So these guys will not bond with anybody. They would be found all by themselves. All right, so with that, that means that these guys are not reactive, whereas we go this way, one valence electron can't be left alone. It's not happy at all, so it has to react. So as we go from here to here, I'm going to color that in nice and neat so we really see that there's a line here. I'm going to have to go through my alkali metals. That's fine. I can still read that. So this way would be increasing reactivity. All right, so that should make sense. So as we're going this way to this way, the 8 noble gases, they're happy. They have 8 valence electrons. They don't want to bond with anybody. They're not very reactive at all. But as I go this way, 1 can't be alone at all because it's looking for 7 more valence electrons so that it can be stable. So increasing reactivity this way. There's also an increasing reactivity as we go from the top to the bottom. Okay. Since we have the page turned this way, we're going to continue with it this way. All right, so we have, we're going to label this in a minute. Okay, so these, which we don't have numbered yet, these are our periods. And it tells us how many orbitals are around the nucleus. And I'm going to show you what that means in a minute. So the periods tell us how many orbitals are around the nucleus. All right, so when I turn the page this way, remember we have these 2 rows down here that have been taken out, but they actually belong up here. So really we have 1, 2, 3, 4, 5, 6, 7 rows. All right, so we're going to go ahead and name them, or number them rather. 1, 2, 3, 4, 5, 6, and 7. All right, and these numbers 1 through 7 will tell me how many orbitals are around the nucleus. So for example, hydrogen. Hydrogen has 1 proton. And if we look at our number here, it's hard to see on the screen, but it's 1.008. So remember, we're going to round that to 1. So 1 minus 1 means 0 neutrons normally. All right. So that makes up our nucleus. And then it has 1, as in a stable atom, 1 electron. So let's just see what that looks like on the other side. So we have hydrogen, 1 proton, no neutrons. That makes up our nucleus. And then we have a ring that goes around to the orbital. We'd have 1 electron. And if we see here, one orbital. All right, there's only 1 electron. So the first ring, this again, we're going to go into this a little bit more detail, but the first ring can fit up to 2 electrons. The next ring can fit up to 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. So let's just test this out about the orbitals. So if we have 1, 2, 3 electrons, let's say. I filled up my first 2, and now we're going on to the second. So that's 1, 2, 3 electrons would mean 3 protons. And I don't know how many neutrons because I need to see what that is. But let's see if the 3 protons, 3 electrons, that would be right here, lithium, fits the 2 orbitals. So remember, we went into the second orbital. And now we can see 6.94, we round that up to 7. 7 minus 3 would give us 4 neutrons. So 1, 2, 3, 4. All right, and then we can continue with that. So we can figure out, if we remember that it's 2 and then 8, if we fill in all of these electrons. We're just going to test that out again. So that would make 10 electrons, which would also mean 10 protons. I'm not going to fill that in because it's getting too tight in there. But 10 and 10, so we're looking for the number 10, which is right over here, neon. So neon filled the full 8. So it doesn't want any more electrons in this outer ring. It's full. It's happy. Well, remember, lithium still needed 7, and lithium was in row 1 with the alkali metals. Column 1 with the alkali metals. So it needed 7 more electrons, where neon, this outer ring, is completely full, and we have 1, 2 orbitals. And if we find neon here, we go along, and we see that we're right. Now, if we add 1 more orbital, that means we need to, if we add 1 more electron, which brings us to 11, sodium, we would need to add another orbital, and that would bring us to 3. So hopefully this is making a little bit of sense where all these numbers are coming from and how important they are to understanding the elements. All right, we are almost done. So at the very bottom, there are 2. I'm going to use gray. There are 2 other things about atoms that I want you to know. One, we could have something, actually I'm not going to use gray, sorry, just changing my color. We could have isotopes. Okay, and an isotope means that it's a different number of neutrons. So for example, we are going to learn about carbon dating or radioactive decay. Everything that's alive, you should have learned this last year in 7th grade, has carbon in it. But the amount of neutrons in carbon is what changes after something dies. That carbon-14 breaks down to carbon-12. So what that's saying is the mass of carbon-14 changes to carbon-12, which means, so here we have 6 protons. So let me use a different color just to show you. So 14 minus our 6. So this has, remember, this is neutrons plus protons, so minus 6, right? And then the same thing, 12 minus 6. So this would actually have 8 neutrons, where this would have 6 neutrons in it. Okay, so this is a mass. This identifies the carbon with the mass. We take away how many protons there are, and that tells us how many neutrons there are. Zoom in. If I zoom in, I'm sorry, it gets blurry. So, I mean, it cuts off. So let me see if I can just lift it up a little bit, and then you should be able to see it. All right. So there are different elements, and we've already learned that kind of with the decimals, depending on the sample atom or the particular atom that we have, it could have a different amount of neutrons. And since the decimal, the atomic mass, is an average of all of the atoms in a sample of a particular type of element, this is where those numbers come in different. And that's why we have a decimal, and it's not a whole number. All right, and then the next one is an ion. And ions are electrically charged atoms. So if it is negative, if electrons are taken away, if we subtract electrons, that means that it becomes a positively charged atom because electrons are negative. So if we start taking away negatives, there are more positives left. So the positives outweigh the negatives, and we get a positively charged atom. Where if we start adding electrons, we get a negatively charged atom. So if we add more negatives, the negatives outweigh the positives, and we get a negatively charged atom. And this is actually how we get things like static electricity, or why your hair would stand up if you rub a balloon against your hair. And I'll hopefully remember to show you guys some demonstrations about that when we are in class with the balloons, and showing you how electrons transfer from one area to another area with the atoms. All right, so this, I think I copied everything down that I want you to know for the periodic table. So now we are going to use this periodic table a lot. Do not lose it. You will need it. What I'm going to suggest doing is actually gluing it right into your composition notebook. If it's too big for your composition notebook, or if you feel like you're going to lose it there, you can put it in like a plastic sheet protector. But do not lose this, because you will need it for quite some time, especially for your benchmark at the end of the year. But we're going to refer back to this a lot. So make sure you bring it with you to class, or if you're at home, make sure you have it handy, so that way we can do a lot of practice with it so you fully understand how to read the periodic table. All right, so great job. This is what the end product looks like. And if you guys have any questions, make sure you ask me when you're in class, or come back onto the Google Meet and ask questions. All right, have a great day.